Electrostatics. What is the definition of electrostatics? A branch of science which dealing with the stationary charges. The charge has to be in charge. Which form? It is in a stationary form. A branch of science which dealing with the stationary charges. That science is called as the electrostatic. That means the charge does not move. There is no momentum for the charges. So, because of this non-movement of charge, whatever the field is existed, whatever science is existed, that is called as a electrostatics. So, this is electrostatic concept. So, before that one, when we are going to further one, we need to know what is meant by charge definition. What is the charge? We are going to consider a conductor. This is a conductor. In this conductor, we know that the conductor is filled with the group of electrons. There are many group of electrons are there. This group of electrons is this is terminal A and this is terminal B, where maximum in which areas the more electrons are presented, that areas are called terminals. So the terminals with more atoms is considered as charge 1, charge 2. What do you mean by charge? Charge is nothing but the group of electrons is assumed as a charge. What is that? The group of electron assumed as a charge. In picture form, how you define? Let we consider a metal body or a conductor. The conductor having two terminals of A and B, where maximum electrons are presented. That particular reason is called a charge. So, just like a magnet, how the magnet is consist of dipole, similarly the conductor also having charges. It is having two charges. How the magnet is having north pole, south pole. Similarly, a conductor or a object of electron is consist of two charges. One charge is a positive charge, the other charge is a negative charge. It's just like a magnet. In magnet we have north pole, south pole. In the similar way, in conductor, we have two charges like positive as well as negative. So this is about the definition of the charge. Group of electrons is considered as the charge. So now here, what do you mean by force? We already discussed force is nothing but this is a certain object. The ability to pull or push of a object is called as force. The ability to pull or push of a object is called force. So here we need to consider a particular field. So in this field we assumed two charges of positive one as well as negative charge. The two charges of positive and negative are affected by a particular charge, are affected by a particular charge. So that charge is what? Sorry, affected by a particular force. వీళ్ళందరూ నిద్రవే రారా గింత టైంకి వస్తారు గ్రూపులు లేరా so these are F, the F is acting on positive charge as well as F is acting on negative charge. And these positive charge and negative charge, both the charges are separated by distance r. Both the charges are separated by a particular distance. That distance is what? The distance is r. So what is that? The positive charge as well as the negative charge are separated by a particular distance that is r. Upon this particular force, upon this particular charges, a force is activated, a force is applied. That force is what? So here your question, somebody is asking that one. So we have two charges and two charges where the force is acting and which area the forces acts and which charge the forces act. So I am saying that one, my dears, the force is acting For example, when you draw a line, imagine line drawn between positive charge and negative charge. Somebody is asking the force is acting on positive charge or negative charge. Where it is acting? So I am giving the explanation to you. The force is acting. The line joining of two charges. The line joining. See, this is the line joining of two charges. On this line joining of two charges, the force is acting. The force is acting. The line joining of two charges. The line joining of two charges. It is working. The force is activated. The line joining of two charges. On where? The line joining of two charges. So these all are predicted by whom? These all are predicted by Mr. Coulomb. That's why it is called a Coulomb law. It is where this Coulomb law we consider in electrostatic. So it is called as Coulomb law for electrostatic. What is Coulomb law for electrostatic? The scientist Coulomb introduced a relation among force, charge, and distance separation are between whom to whom? The scientist Coulomb is introduced a relation among the force, charge, and their separation distance. So this relation is considered as Coulomb law for electrostatics. In briefly, how you explaining this Coulomb law? For this, we need to consider two charges. We need to consider two charges of positive, of negative. The two charges are separated by a particular distance r. Upon these two charges, let we introducing a force F. Now we already discussed the force is acting on the line joining of these two charges. So from this figure, we illustrate that whatever force we consider, the force is proportional to the product of charges. I consider this is charge 1, this is charge 2. So the force is proportional to product of charge 1 and charge 2. Similarly, the force is inversely proportional to their square distance. Here, why you consider square? Somebody is asking, sir. In formula we have, in figure we have only r, but why you choose r square in formula? Because when compared to the r, the value of r square is greater than. Why? Because when you reduce or when you increase the distance separation between two charges, then the value of f will decrease. Clearly, once again, if you increase the distance separation between two charges, the distance separation between two charges, what is happening? The value of f is decreasing. The value of f is going to be negligible. To avoid this negligible concept, we took in place of r square. We took r square in place of r to avoid the negligible character of force, to avoid the negligible nature of the force. That is the reason in place of r we consider r square. This I can consider equation 1. This is the equation 2. So from equation 1 and 2, we simply consider f is proportional to q1 q2 by r square. Now you remove the proportionality. F equal to q1 q2 by r square. F equal to what amma? K into q1 q2 by r square. You know very well about what is K. K is nothing but Coulomb constant. Q1 is nothing but charge of positive. Q2 is nothing but charge of negative. R square is nothing but the square of the distance between two charges. This is about the Coulomb law for the electrostatics. So this is the Coulomb law concept. Then again, we need to discuss about the electric field. What do you mean by electric field? Let us consider a certain area, certain field. The field is if it is influenced by force and charge. Force and charge. A field which is experienced by force and charge. That is what? That is electric field. A field which is experienced by whom to whom? Which is experienced by force and charge. That field is called electric field. Electric field definition is what? A certain field which is experienced by electric force and electric charge. Electric force and here force means we need to consider electric or electrostatic. So here a field which is influenced by electric force or electric force and electric charge, that field is called as electric field. Therefore E equal to F by Q. E equal to what? E equal to F by Q. That's it. This is definition of electric field. Now somebody is asking, what are the dimensions of this electric field? The dimensions. Yes, you know. What is F? That is Newton. What is charge? Coulomb. So the dimensions of electric field is what, Amma? Newton for Coulomb. That's it. This is the dimension of electric field. Coming to electric potential. What do you mean by electric potential? Simple one. Again, you consider same electric field. We consider same electric field. I consider same electric field where F is there, where charge is there, where is nothing but electric field. So here in this particular field, there is a charge is present. A positive unit charge is presented where at position A the position B. So here what I am going to do, I am displacing this positive unit charge from where to where? From position A to position B. What I am doing, I am displacing positive unit charge from position A to position B. Then for this displacement is happening because of certain force. Is it right? Because of certain force, the displacement is caused by certain force. Then force and displacement together is called, the force and displacement together is called what? Work. What is that? Work. What is that? Work. What is work? Work is nothing but force and displacement. Force and displacement together called as work. Here in electric field, why work was done? Why the work was done? The work was done in electric field because to move the charge from position A to B. Is it right? In electric field, the work was done. Why it was done? Because of to move the charge. Where to where we are moving? The charge is moving. Which charge? The positive unit charge is moving from position A to position B. For this particular displacement is because of the force. So the force and displacement both together are called as work. This work is because for the displacement of charge. So here the work done to move a charge. What is that? The work done to move a charge is called as electric potential. The work done to move a charge is called electric potential. Let's see what are the dimensions of the electric potential. Electric potential dimensions V equal to W by Q. What is V? V is nothing but Fs by Q. Then what is F? Newton. For the displacement is what? Meter. Newton. And charge for Coulomb. Then the dimensions are what? Newton, meter for Coulomb. Newton, meter for Coulomb. These are the dimension factors of the electric potential. Then coming to the Gauss. What is mean by Gauss statement? Gauss law is related to the closed surface. Where is that? It is related to the closed surface. What is mean by closed surface? So what is mean by closed surface? Just take a particular surface. Which surface we need to take? Take a spherical shape. So in the spherical shape, we could not find any boundaries, any edges. No boundaries, no edge. A surface without any edge and boundaries. That any edges, no edges. A surface without any edges. A surface without any edges is called as closed surface. So here the Gauss law is related to the closed surface. So what it is? Let us consider a closed surface. In a closed surface, the net electric flux, the net electric flux, the net electric flux, whatever net electric flux is there, the net electric flux is equal to 1 by epsilon naught times 1 by epsilon naught times to the given charge. 1 by epsilon naught times to the given charge. So what where the charge? The charge is presented to the this particular closed surface. So the charge is presented to this particular closed surface. So here, so let we need to talk about what is mean by electric flux. What do you mean by flux? Flux is nothing but I have to consider certain area. This is nothing but electric field. Through this electric field, the number of imagined lines are passing. The number of see electric lines are not real. They are the imagined concepts. So this through this certain area, whatever imagined lines are passing, that number of imagined lines passing through this unit area is called as electric flux. It is represented by symbol phi. So here it is electric. So we consider electric flux phi E. Phi E is the electric flux. The number of lines passing through a unit area of electric field is called electric flux. Is it right? So this electric flux in a closed surface is equal to 1 by epsilon naught time to the given charge or to the enclosed charge. In a closed surface, whatever charge is there to this charge, it is 1 by epsilon naught times. So that is considered as the electric flux is equal to 1 by epsilon naught times to the given charge. This total is considered as this equation or statement is considered as Gauss statement for closed surface or electric flux character. So this is about the Gauss statement. Again, we need to discuss few factors about the characteristics of the charges. Characteristics of the charges. What are the